Okay, cool. Hi, everyone. My name is Liann. I'm one of the RAs for this workshop. There's 4 of us walking around. Gabe in the back is going to present next. Tom, also in the back, and Madeline, who you can also thank for organizing all the food for this week, and basically doing all the organization with Jim. But anyway, so I'm one of Jim's students, I guess maybe former students now. I just finished my PhD in the sociology department here. And so we're going to do a really quick and compressed version, if you've been here before or seen the online videos of Maria Christina's training on how to some basic R stuff and coding, and then how to kind of get your raw data or survey data into the format usable for network objects or graph objects in R. So I don't think this is going to take the whole time, and it's going to be really quick, so it's either going to be boring for those of you who've done it before, or maybe overwhelming if you've never done it before. So everyone's going to be a little bit confused, but either way. So first thing I want to mention, if you don't use R, if you haven't, if you're new to it, or if you only use it for network stuff, just some clarity when we're talking about these terms in coding. There are 2 programs essentially that you're kind of using. There's R, which is the actual statistical programming language, and then RStudio, which is the IDE that you're actually using to do all your programming and coding. And the best way I can think about it is that R is the engine under the hood doing all the work and all the statistical mumbo jumbo, and then the RStudio is the environment that lets us kind of see what we're doing, keep our script files all saved and organized, and just make the user face a lot more friendly and easier to use. So again, if you're new to R, just really quickly, I want to kind of tell you what the RStudio format looks like. When you open it, this is what it looks like as a blank screen. Your top left corner is what we call your source. So if you are saving files or writing code that you want to save for later, which you should, that's where you would write all your source code, and you would save those either as script files, which is like your notepad on your desktop computer, or TextEdit if you have a Mac. And if you have a Markdown file where you're creating presentations, so all of this I made in Markdown, that will all be in your source code here. When you run something from your source code, it gets passed through to the console, which is down here. And the console is actually where R's engine is that's doing all the work. So you'll see a bunch of lines happening here when you're running code, and all your error messages will pop up here as well. You can run stuff directly in the console, but you will not be saved. You're doing quick calculations is usually what I use it for, but nothing that I want to refer back to later because it will get lost. Over in the top right is your environment and history. So most of the time, this is where you'll be looking for what objects you have in R. Again, if you're new to R, it's an object-oriented language, so everything you do gets saved as an object, and you can see what you saved in here. So your data files, if you do some calculations and you want to save it, if you have any functions you've created or have saved from different Stack Overflow sources, those will all end up in the environment panel here. And there's a little history tab button that can show you stuff you've run if you happen to run something in the console and you forgot to put it in the source over there. And then finally, the last pane over here has your files, so what your current working directory is. That's whatever folder you're saving all of your R files to, whatever you're pulling out from if you're keeping your data there. It also has where your plots will show up if you're making those, and where all your packages are, and your help tab as well if you need to reference back what certain functions need to work properly. And feel free to stop with questions if you have any. Okay, and so another last kind of brief, very intro to R thing. Again, Maria Christina has a much more in-depth version of this online on our training website, videos, and code and everything. A couple of operators you should be aware of using in R. So the first one is this C with the parentheses, which is a function that creates a vector, so just a little store some information there. You'll see that in some code I put up later. So we use that sometimes to create an object of either kind of strings or numbers, anything that we want to store as a group. The little arrow operator, so it's a bit small, is how we assign whatever we're doing in R to an object. So when you want something to be saved, either a data set or a function or some calculation you're doing, you'll use the arrow function, you'll give it a name, put the arrow, and then whatever code you're writing on the right-hand side, and that'll make it so that whatever you run saves into R. You can see that in an example here. So if we're using this kind of vector function up here, and we create this vector of numbers, the arrow assigns it to this term, my numbers, and it gets saved in our environment. One thing to note is that these objects are case sensitive, and you can't have spaces in between them. So just be careful when you're naming things, not to make them too crazy long, but also something that you will actually remember, and not just the same word over and over again, like I've done sometimes and then get really mad at myself for. The last one is a pipe, which I think there's a few ways people do it now. This is the one that I learned and I'm most familiar with. It's an operator that basically in the R language tells you and then. So instead of writing a bunch of individual lines of code and reassigning it to a bunch of objects, the pipe operator lets you write a line of code and then do something else. And when we get more into the creating network objects, I'll show you what that looks like. But the and then part is the useful way to kind of remember what it does. And these will all be posted online too, as well as the actual markdown file I used to create it with all the code. Okay, so I think the fastest kind of overview of what R does. And the rest of this presentation, I'm going to kind of show you how to get from your survey data or whatever you have into a graph or network object that would set you up for the rest of kind of analysis we do in this class or calculating different measures that Jim mentioned in his previous presentation. So the most common packages in network analysis are StatNet and iGraph. They're both really powerful and really fun. However, they are also incompatible because that's what R is like. And if you want to use both, which we all do often, there is another package that someone very kindly created that I'll show you called Intergraph. So if you create your network object in one, you can easily transfer it to a different one, and it makes it slightly less painful to go back and forth between the two. Because of Maria Christina's tutorial, she used StatNet. I'm going to use iGraph just so both are like relevant or up there online once this is over, and also because I pretty much exclusively use iGraph, so this is also a selfish choice. But the cleaning data, the setting it up is essentially the exact same for StatNet and iGraph. It's just once you get to using those packages, that's where it changes a little bit. Some useful packages, ones that I will be using here, not an exhaustive list, but just ones that I use pretty much every day is the tidyverse, which is a collection of packages. If you're aware, it's really popular now in R. It makes cleaning and manipulating data a lot easier. It takes a lot of code from SQL, or style of code from SQL, and it just makes the whole thing process much easier than doing it in base R code. ggplot2 for creating visualizations. If you're doing kind of like basic plots of the data you have just to check on it. That's usually what I use. And then, of course, iGraph and StatNet that we have. iGraph to create your networks and calculate some basic measures. StatNet are the collection of packages where you can actually do the statistical analysis of the networks. And then Intergraph to go between the two. I would highly recommend not having StatNet and iGraph loaded at the same time on a package, or for the packages in R, because they have the exact same name for some functions, and it's going to cause you some problems. So just make sure if you're using one not to have the other in there and then unload it when you're switching back and forth. If you have no idea what that means, we can help you with that. We're available throughout the week, basically, if you need some extra coding help or have questions about anything that's going on this week. Okay, so to create a network object, the first thing we need are kind of two files. We need our node file, which is a data frame of all the individuals or organizations, depending on what your level of analysis is in the data set. And then the second file is your relationship structure. And the relationship structure file can come in a number of different ways. It's just depending on your own personal preference or the data set you have. The most common ones we see are the adjacency matrix and edge list or arc list that Jim showed you earlier, and I'll show you some examples. And then if you have two-mode network data, so people as a part of organizations, or something that has multiple levels, we would have a bipartite or two-mode matrix. So usually we take our original data set, the raw format, and we create these two types of files to combine together in order to create our network object. So the first one is just an example of what an adjacency matrix looks like, what you saw from Jim, but this kind of shows you some really simple code to make your own to play with as you're learning more of these methods. So on the in the rows is everyone's individual name that's here, and on the columns, again, is everyone's name repeated. This is a binary network, so the zeros mean there's no tie between these people. The one means there is ties. There is a tie. This is one of the simplest types of matrices. As Jim mentioned, there are more complicated ones. If you have negative ties, like kids bullying each other, you might see a negative one in there. Or if the ties are weighted, you would see different, not just ones and zeros, but different numbers on there as well. An edge list is, instead of having everyone in the rows and columns, you have each individual person has their own row, just like you would a regular data frame. But instead, the identifying kind of variables are the first two columns. So you have person one here, and then nominating to whatever person is also in the data. So if you have kind of multi-wave data as well, so over time, each person might have also multiple rows. If they're connected to multiple people, they'll have multiple rows. It basically transforms it from like a big 2x2 or however many to just a long form data format. And the rest of the code in this presentation will show you how to get there, because I think the edge list is one of the more popular ones to use when creating these objects in iGraph. And then finally, just an example of a bipartite matrix where we have all of our names here individually in the rows, and then all of our affiliations in the column, and we can use that to create a network where we are connected to each other even if we're not directly nominating each other like we would in most networks, or in some networks. So the first three examples were ways that you can have your relationship structure file. This one is what you would definitely need to have, which is your node list file, or the individual attributes for every person in your network. So here I've used all of our names. We might give ourselves ID numbers in addition to having our names in there, and then some kind of individual attribute information about us. So we can combine those with the relationship structure files and have information about the individuals as well as the connections between each other. Everyone with me so far? Okay. Okay, so this, the rest of us, we're going to go through the process of how we get to the network structure. This is highly adapted from, if not directly copied from, Maria Christina's work, because she's who I learned from when I was starting off doing these network procedures. So the first thing we're going to do is look at the raw data we have, the survey data. The next we're going to do is make a plan, not go straight into coding, because that will always lead to more errors. And then we're going to work on cleaning our data, getting into a graph object, and then we're going to double check that what we made is actually what we wanted. So in the inspection, evaluation of our data, the first things you want to make sure you have are whatever pieces of the data you need for the network object. So what are the variables in your data set that are going to be attributed to the nodes, so the individual people or the organizations, and what are the pieces that are going to be attached to the edges, so the edge attributes. And I think this is where some people get a bit confused when I've taught this before, is that the edge attribute, or kind of variables belonging to the edges, has to be some kind of variable related to the tie itself. So how often two people interact, to the weight of the edge, weight of the edge, whereas the node characteristics are specific to the individual. So it's individual versus the two ties together. And then once we know what we need, we have to go through the issues. So obviously you want to clean all your data before you go to the network side, otherwise you're just going to have to redo everything. So the issues you might have to deal with at the observation level, whether or not there's missing data or there's stuff you need to recode itself, or if it just looks kind of wonky, nonsensical or missing values, so making sure you recode all your 99s to missing, or getting rid of missings if you don't need those. And at the structural level, making sure that all the columns you had are what you actually need, especially if you're getting data from things like Qualtrics that add extra columns or rows in there that are not really necessary, but just are part of the structure of the system itself. And just making sure, again, everything's in the right format that you need it to be. So basically, all to say is to just kind of look at your data physically in the spreadsheet format before you do anything, and make sure it looks how you expect it to look. What we want at the end of this is a spreadsheet that has all of our individuals, who they're tied to in some format, so we can manipulate it later. Again, don't start manipulating are doing anything before you figure out what you need to do. Get a good sense of what you have at first. Something that I do that helps me a lot if you're a visual person, which if you do enough network stuff, you will become a visual person, is to actually draw out what you need. And it's easy to go back to be able to figure out what you need to do later. And it makes you have a lot fewer errors as you're doing all this out. Okay, so once you've inspected your data, then you go to the making a plan stage. And again, this is where we're not coding yet. We're still just writing everything out, figuring out what we need to do before we actually jump into the data set itself. So coming up with your series of tasks you need to clean the data, but also to get it in the structure you need it for the network. Again, removing missing values or imputing, that's your decision based on your data. You know it best. And then how to restructure the data set. So if you want to use an adjacency matrix versus an edge list, those are all decisions you have to make that you need to decide what's best for your data set because you know your data set best. Okay, so once you have your plan laid out, then we're gonna actually go in and cleaning the data, structuring it, and creating our network or graph object using our network analysis package. In this case, we're gonna use iGraph to create our graph object. And then finally, we're gonna go back, check your work, make sure it looks like what you think it looks like, either by doing some basic descriptives to make sure that it makes sense. Usually as soon as I create a network object, I plot it straight away to see if anything looks crazy or if it isn't behaving the way I think it should be behaving. Okay, so I'm gonna go through an example. I'm not gonna do hands-on coding with this. I'm just gonna show you code and sometimes some results since we've done most of this before in previous years. And again, you can run this all yourself online or take code from here afterwards. So the first thing to do is loading packages you know you're gonna need. So loading my cleaning packages and my iGraph package. And we're gonna use a kind of fake AdHealth data set, so a survey data set. If you're unfamiliar with AdHealth, National Longitudinal Study of Adolescent Health, where kids were surveyed about their health behaviors in addition to asking who their closest 5 male and closest 5 female friends are. So it gives us quite a big network to work with, at least for them. So what we want to do first is understand the structure of our data, and there's a few commands that can help us with that. The first is to make sure that it's actually imported. When you've imported it here, if it's been as a CSV or a SAS file or as an Excel file, that it actually has saved to your R environment as a data file or data set. It's what we usually need to work with these objects. And so the class function can tell you what kind of class that object is. In this case, it would show us as a data set. You can also specify for different variables within your data set to see what those class options are, if changing those is meaningful to you. We can also see what all of the names are in the variables or the column names to get a sense of what we have. Usually we don't need all of the columns that we actually do have, so it's helpful to get rid of those. For this purpose of this kind of tutorial, we're gonna look at these variables. So all we really need is our ID for the ego, all of the friends nominations they did, and then just some basic node attributes, so their sex, their grade, and what school they are in. And we're just going to subset all of this for the purpose of this exercise to school 7 out of I think there are 130 or so. So a couple of other functions that are useful as well is glimpse, which is part of the tidyverse that gives you a list of all of the variables you have, but also tells you what class they are stored in. So if you have some numbers that should be characters or something along those lines, you can check that through there and it'll list them all in a pretty neat way. Again, making sure that you know your data best, so going in conjunction with your codebook or survey, looking for red flags to point out, so your missings or your 999 variables, and either removing those or recoding them so that you know what those are. So a couple of other useful functions are head and tail, which basically shows you the first 6 rows of observations or the last 6 rows of observations. You can also add a number as an argument, and it'll give you as many as you've asked for, essentially. And then the summary function, if you do it on the entire data set, will basically give you your 5-number summary for every single variable you have in the data set, where it makes sense. If you have a factor or character variable, it'll give you a proportion or the number at each level that you have. Okay. And the next is probably a review for everyone, basically your basic data exploration process when you're looking at your data. This is not kind of restricted to networks. This is just how we all do analysis, hopefully. So making tables for your variables of interest so you know which ones to keep. So usually we'll do a couple of cross tabulations or just simple like counting of who's in what. So just here, I created a table of just how many kids are in each grade. This one I think is recoded differently, but just to get a sense of who's there so you know if anything's super wonky. So some basic tables and then some cross tabs, especially if you're using, if you know you're going to use certain types of variables and want to know, get some basic ideas of if they might be related or not. Again, this is basic data kind of management and exploration before we're getting into the nitty-gritty side of the data, of the network side. And lastly, again, doing visualizations, not just for the networks, but then also just doing basic kind of data exploration visualizations is really helpful to understand what's going on, especially the network side. So this variable specifically, I just made a bar plot of everyone's total nominations for friendships in AdHealth, just to see what the distribution of that is like. That might be helpful for me later, depending on my research question. Okay, so we've looked at our data. We kind of have an idea of what the structure is, and so now we need to deal with it. So again, we're not going to jump into coding straight away. We're just going to kind of make a plan of what we're going to do. Again, I'm going to do an edge list for this example. You could do an adjacency matrix if you wanted to. I find edge lists easier to work with, at least for this type of friendship nomination data. So constructing an edge list takes a few steps. First, we only want to look at school 7 for this, so we have to filter out observations so that we only have people who are in this specific school. We're moving our nominations from wide to long format. So if you think of a survey where people are nominating each other, usually for every person you'll have like friend 1, friend 2, friend 3. So we want to make sure that each person and their alter has their own row for each other, because that's the way that iGraph understands edge lists to be able to make the graph object. And then either removing or recoding, depending on how you're handling missing data, your NAs and your 999 values. So that was our plan for our edge list. And our plan for our node list is, again, to also filter the original data sets, so we only have school 7. You really need to make sure that you have matching edge lists and node lists. Otherwise, you'll get a lot of errors. Usually, if it says it doesn't exist, or you have extra vertices or something, that's usually a filtering problem in this way. And then for the node list, you want to select the columns or individual node attributes you want to keep for your analysis if they're relevant. Okay, so constructing our edge list. The first thing I'm going to do is create a new little object that's just AdHealth School 7. Something I also should be better at, and we should all do, is making sure you don't rewrite over your object names, because then you just end up having to rerun the entire code all over again. And as much as I say to do that, I also don't listen to my own advice most of the time, and then I regret it. So creating a new object just for School 7. The filter function is part of the tidyverse range of packages. And again, I think that's based off of SQL code. First argument is just the name of your data set, whatever you named it, and you want the variable for the school is to equal 7. And then I just wanted to check to make sure that it looks like most of them are 7, so I called head the first few rows of my AdHealth School 7, the new object, and it looks like all of them are there. It's definitely cut off, but just to see what it looks like. And then step 2, I want to move from wide to long format. So this is where those pipes come in, because I'm doing a couple of steps each time. This is not necessarily like the best or fastest way to do it, but this is the way I learned. So as with everything with coding, it's either who taught you first or which Stack Overflow page you landed on. And so this is what I've been doing for as long as I've been working with networks. So the first function select is also from the tidyverse package. What I'm doing there is, because this is an edge list, and I don't have any edge characteristics, I just want the IDs of the individual person and then who they nominated. So what I've done here is I've called the school 7 the ID variable, and then all their male friend nominations and all their female friend nominations. And then with the pipe, pivot longer is also in dplyr, or in the tidyverse, that'll shift your wide data set to long. I don't want it to do that to my ID column, so I put the calls argument, I put negative ID, so I want it to shift everything except my ID column. Then it'll shift it to long. And then I'm using select again as sort of a cleanup, where I want to make sure my ID number is first, and then the value creation with the pivot long function is where all the friend IDs end up once you run this function. And I'm just going to change that to alter, just for my own sake, since I know what that means. And lastly, want to make sure if you have any 999s or NAs, they'll still show up in the edge list. It'll just be adding more rows with your kind of egos ID and just NA or 99. And so I want to get rid of those. So I'm filtering out all of the alters that are equal to those 99s, and then I'm dropping any NA values from this edge list. So then when I've saved that to the edge list object and run this kind of head on my object again, you'll see I just have my edge list, which is just two variables, all of my egos, and then who they nominated. So this person, node 1, will have as many rows as people they have nominated in the network. Okay, so now you have your basic node, your edge list. Usually it's not that clean. Probably ran into 7 errors making that, and you'll kind of go back and forth constantly. Now I want to construct my node list to make sure it matches. So I'm going to filter out my add health original data set again, make sure that I only keep people in school 7, and then I'm going to only select the variables that I know I want to use in this analysis or that I want to have in my actual network object. So I'm keeping their ID numbers to make sure it matches the edge list, their sex, grade, and whatever race they have identified as. And then just checking again that it's done what I want it to do, having a smaller little node list that makes sure so that it matches my edge list. Okay, so once I have those node lists and edge lists, I can make my network or my graph object in this case. When using iGraph, we usually refer to them as graph objects. If we're using StatNet or the network package, they're usually referred to as network objects. They're really interchangeable, but it's just kind of how people talk about them. So I'm going to create a new object, which is my add health graph. I'm going to use the graph from data frame function in iGraph. The first argument, labeled D, is your edge list. The second argument, labeled vertices, are your nodes. And then depending on your data set, you can say whether it's directed true or not. This is a friendship data set, so they are directed. So I've added directed equals true. I believe the default is false. So if you know that they're directed has meaning, make sure you add that in there. And then I just ran the object just to make sure it looks like what I thought. So if you just run an iGraph object with nothing else, it'll show you this kind of summary of some of the connections and the attribute names, so you know it's worked. Okay, so I have my iGraph object now, and the first thing I want to do is plot it to see what happened. So the plot function, if you just plot the actual iGraph object, it'll spit out iGraph's kind of standard way of plotting graphs, which is usually really ugly and turns into this hairball. And it's not useful, but at least it looks something like what we think it should look like. I prefer personally to use gggraph, if anyone's used it before, for plotting the graphs. It has similar syntax and kind of just way of thinking as ggplot2. And I find it a little more flexible and generally prettier, which is what we care about. So when I'm making the plots, I'm going to show the code first, then the plots, because there was just too much to put in there. It does require a little bit more code than the native iGraph plotting sequence does. So I'm just loading up a couple of packages you need. For gggraph, you also need a package called tidygraph, which changes your graph object into kind of a little, into a structure that gggraph can use. So what I'm doing here is I'm taking my add health graph, passing it through this tipple graph argument, which is from the tidygraph package, creating a layout. There's a ton of layouts. I think Jim showed you some of them in iGraph and gggraph. One of the most common ones is FR. The other one's KK or stress. There's some auto ones it does. And I've taught this before. Most of the time I'll just tell students to just find a list of everyone and just try to break something, because that's usually how I learn, by trying to break my code. Or see what works out best. So once I've created the layout, then I'm just going to pass it through the gggraph argument. And then what's different about the gggraph package versus just the iGraph package is it works in layers just like ggplot2. So you have to add a layer for your edges, which is just geoMedge link, and then add a layer for your nodes. and a couple of arguments in there to color them so you can see them better. And then the gggraph authors create their own theme so it looks like a white background. You don't have the automatic X and Y axes that you might when you're doing a ggplot graph. So this is what it looks like with that code. Still kind of hairball-y, but better than the iGraph code by itself. We can also see that there are some isolates in this network that I didn't get rid of that might be useful for you to have. You might want to get rid of the isolates, just depends on what you want to do. If you do want to get rid of the isolates, I add this line of code, which is from the iGraph package, which is just I'm deleting all of the nodes where the degree is equal to 0, and then I'll just get rid of all of them so you can only see the ones that have connections. And then I'll spit out this plot. So you still have a couple people who are only tied to like one other person, but it just gives you these two components in the network. And then, oh, sorry, question? Yeah.
When it calculates measures like density or all the centrality or all things, it includes the isolates in those calculations, correct?
Yes.
To delete them visually, it's still calculating them because of the attribute list that you have, right? Like if it's trying to calculate school 7's statistics, it's including all the isolates, right?
If you keep them in, yes. So if you delete them from the graph object, it'll delete them from the node list and the edge list. So yeah, so the statistics itself, I didn't change the graph object in here. I was just piping it through. Anything you pipe through doesn't save, just for the plot itself. But yeah, so if the isolates are important to your measures, then don't delete them. Does that make sense?
And you have to have that ego list for the program to know, because an edge list doesn't include any isolates.
Exactly. So the way that I do it here, you could just create the graph object with only an edge list, but then you would have to add the attributes on later, which I found kind of finicky in iGraph and doesn't always work very well. So the easiest way I found is to have the attribute list as well to add it in. The only issue with that, as I mentioned before, is that everyone in your edge list in the ego ID or the alter also has to be in the node list. So if you have somebody like who wasn't there that day at school, who's in the edge list, you have to add them to the node list, even if they have missing values on everything else, just to make sure they match. And you'll usually get an error if you don't have them with iGraph, saying like there's a vertice that doesn't exist in the edge list, but we usually just kind of add a row for them so they exist, so that we can create our graph after that. But that's really like you might get some missing data with those kids, or respondents, whatever you have in their node attributes. Does that make sense? Okay, I think this is the last one I did just to show you how you can manipulate it a little bit. So as part of a kind of checking your work thing, I want to see if the graphs are plotting and kind of behaving as I thought they would. So because this is a school network, and we know that kids tend to be friends with people of the same sex or gender as them, I decided to color the nodes by sex, whatever they reported in the survey. And so I added these arguments to the geom node point side where just basically filling the circles by, I think it's coded as 1 or 2 here. It has, again, the same syntax and kind of logic as ggplot2, where if you're taking, if you want to color something by a variable in the data, it has to be in this aesthetic argument in order for it to work. Okay. And the shapes argument, for some reason also, is necessary if you want to use the fill argument. There's a list of like 20-something shapes online. 21 is the circles, which is our most common shapes for nodes. That's usually what my default is. So here, sort of plays out kind of how I would think. You see a lot more people of the same sex close to each other, sort of kind of cliques of people of the same sex. And then it adds a legend automatically, which you can also edit later the same exact way you would edit a ggplot2 legend as well. And so those are the kind of checks I do when I'm like checking my work here. The visual, I think, is the most useful way to make sure that everything's looking as it should look. But yeah, and I think that's all I have for everyone. Yeah, thanks.
Fix that grade, the junior high, I'm guessing, 7th and 8th graders on the top, and high school at the bottom.
Yeah, so I think in middle school they couldn't nominate people across grade, or no, the junior and high school.
A lot of people, we made the fake data, we
Okay, yeah. So some of the adolescent data sets and other ones that I work with, sometimes they can't nominate across grades, so you'll see these really distinct clumps that probably aren't real, but separates them out. Was there another question that I heard?
That was my same question. I'm like, this is one school. What's
Oh, yeah.
Don't take any substantive conclusions from the big ad health data set.
Yeah.
They are deliberately made up because we didn't want to get in trouble.
Any other questions? Yeah. No, so this was just for an example show, but the iGraph package, so I use the graph from data frame function. There's also a graph from matrix function as well. The iGraph package, lots of our packages are not well documented because it's open source, but the iGraph package is really well documented, at least in my opinion. They have a Python and an R version, so if you find, we can probably send around to you, or if there's a link somewhere. The iGraph package will tell you all the different ways you can make the graph object as well. You can also, if your brain works more in edgeless than in matrices, you can also go from a matrix to an edgeless and then put it in that way. It just really depends on personal preference. Any other questions? Thanks, everybody.